My name is Atta-ul-Latif. Today I will discuss AS A-level physics paper that is related to Cambridge International Examination. Okay, code for this paper is this. 1 stand for the paper 1. O and N is stand for the represent the month. So O stand for October, N for stand for November, and 2018 represent the year of the exam, that is 2018. Total time to solve this paper is 1 hour and 15 minutes. So, but I will discuss this paper with complete detail. So let's start from the question number one. The question number one is about the radius of Earth is approximately 6.4 10 raised to power 6 meter. The radius of moon is approximately 1.7 10 raised to power 6. A student wishes to build a scale model of the solar system in the classroom using the football of radius 0.12 meter to represent the Earth. So, which object would best represent the moon? As according to given data, the radius of Earth is given 6.4 10 raised to power 6 meter. Radius of moon is approximately equal to 1.7 10 raised to power 6 meter. So a difference in radius that will be equal to 6.4 minus 1.7 10 raised to power 6 meter. Okay. So that is equal to 4.7 10 raised to power 6 meter. So which object would best represent the moon? Okay, if 0.1 meter to represent, mean if the football is representing the Earth, so tennis ball will be the best representation of the moon from the given choices. So A is not wrong, B is wrong. So B will be answer. Okay. Question number two is when the beam of light is incident on the surface, it deliver energy to the surface. The intensity of the beam of is defined as energy delivered per unit area per unit time. So according to given data, the intensity is energy per unit area per unit time. As we know that work represent the energy, so I may write the that I may replace energy with the work, and A represent the area, T represent the time. Work representing by the force multiplied by distance covered, and A T. But we know that force is sorry. We know that force is actually the mass multiplied by acceleration and length and A T. But what is unit of mass? Unit of mass is kilogram. A is representing the acceleration. Acceleration is meter per second square. And unit of length is also a meter. Unit of A is area is meter square because area represent the multiplication of two length and T represent the second again. This m square will be cancelled with this m square, and so the result will be a kilogram second cube. Okay, or you may say that kilogram second minus 3. Okay, so D is the choice. D will be the answer. Okay, according to this. So next third is question is a ship is travel with the velocity. Sorry, ship is travel with the velocity is 8 kilometer per hour. The direction Direction is 30-degree east of the north, east of the north. Okay. What component of the ship velocity in the east and the north direction? Okay, if we draw, if we represent the this will be north, this will be represented by the west, this will be east, okay, and this will be a south. As the angle is 30-degree east of north, east of north, so east of north mean that is making angle 30-degree with the north, uh, in the section of northeast, okay, and that will be make angle 30. Okay, and traveling velocity is 8 kilometer per hour. Okay, so as we know that the uh, the length in front of the angle will be representing by sine, so that will be equal to 8 sine 30, and along the angle is representing by the 8 that will be 8 cos 30, okay, and that will be this. As we know that 8 sine 30, yes, we have to check. Uh, so this is along the east, okay, and this will be along the north, okay. So 8 sine 30 is equal to 4. So the 4, that may be a 4, and 8 that may be a possible. Sorry, this may be this. Okay, 8 sine 30 is east, along the east is 8 sine 30, that is equal to 4, and 8 cos 30 is 6.9. Okay, 6.9. So the choice will be so answer will be a B. Answer will be a B. Okay. Okay. Now move toward the fourth question. Okay. The fourth question is about is micro screw gauge is used to measure the diameter of copper wire. Okay. The reading with the wire is position is as shown in figure diagram. Shown in diagram 1, the wire is removed, and jaws of the micrometer are closed. The new reading is shown in diagram 2. So diagram 1 will be uh, represent the actual measurement, not actual mean that will be represent the measurement, and diagram 2 will be is related to the uh, zero error. So if zero coincide with the zero, then we don't need to need diagram 2, but here is a error. Okay, this is the actually the zero error. Okay, this is a zero error. Okay, so diagram the reading from diagram 1 is sorry, the read 2.1 2 1 and 2 0 1 2 2.5 reading reading from diagram. One is 2.5 and this is 9. Okay, so plus 9 divided by 100. Okay, so that will become 2.5 plus 0.009. Okay, so result will be sorry, not 0.0909. Okay, so the reading will be a 2.59. Okay, so that will be the reading 2.599 millimeter. Okay, uh, now about zero error. So zero error will be equal to, yes, zero error is one, yeah, this is a 14. Okay, so zero error will be a 14 divided by 100 and that will be equal to 0.14. Okay, so diameter of, so reading will be so so diameter of wire will be, we must subtract the zero error, so that will be a minus 0.45 and that will become 2.45. Okay, and 2.45, that is, sorry, that is B. Okay, now move toward the fifth question. The digital meter has accuracy is 1%. Okay, meter is used to measure the current in electric circuit. The reading on the meter varies between 0.34 and 3.8. So what is the value of current and with its uncertainty? There are two type of uncertainty. Okay, we have to consider both two type of uncertainty. First one is the given, that is 1%. That is 1%. 1% mean 1 divided by 100. That is 0.01 is due to fluctuation. And that is what is the fluctuation? Fluctuation is 3.08 minus 3.04. Okay, and divided by, because these are the fluctuation between two readings, so that will be a 0.04 divided by 2, that is equal to 0.02. So one is this and one is this. Okay, average reading will be, yes, that is 3.04, 3.08, sorry, and plus 3.04 divided by 2, that is so the result is 3.06 ampere. Okay, and total uncertainty will be, so total uncertainty will be 0.02 plus minus 1%, that is 1% of 3.08 0.06 divided by 100. Okay, that is 1%. Okay, from this. Okay, so that will become total will be a 0.02 plus 0.036. Uh, so that is equal to 0.056. Okay, that will be plus minus uncertainty. Okay, so so reading will be from this reading will be 3 point uh, 3.06 plus minus 0.056. 0.056. So the best answer is C. 3.06 plus 0.505. So that will be the answer C. Okay. Because this was the error. Okay. Total uncertainty and this. Okay. Now move toward the second question. Okay. That is the sixth question. Okay. This is related to a tennis ball is thrown horizontally in air from the top of the tall building. Okay. The effect of the air resistance is not negligible. That is very important point. That is not negligible. What happened to the horizontal and vertical component of the ball's velocity? Okay. The tennis ball thrown horizontally from air top of the building. Okay. Ball is thrown horizontally. Okay. When ball is thrown horizontally, it means it moves in this way. Okay. So the velocity will have a two component. One is along the horizontal and one is vertical component. Since velocity is toward this, so horizontal component of Fs will be reverse direction. Okay, horizontal component of resistance will be in opposite direction. So so the constant horizontal component of velocity, that both are wrong. So no, the choice is because there is air resistance opposite to the velocity and it will resist the horizontal component of velocity. So that's why the velocity will decrease to zero. So that will be possible and that will be possible. Now the what about the vertical component of velocity? Since this is a vertical component of velocity, okay, and we know that vertically there is a gravity and that is also downward. Okay, uh, gravity will be downward acceleration, but when v is downward, the fs will be upward, friction force will be opposite, so acceleration will be and so it's mean so Fs will friction force will be upward and but velocity will be downward. But because acceleration is toward the downward and velocity is also a downward, uh, so velocity will be increased when mass will be moving from up to down. So velocity will be increase. So the maximum value. Okay, so that will be the answer. Answer will be a D. Now move toward the question number 7. Water is pumped through the hose pipe at the rate of 90 kilometer per minute. Okay, water merge horizontal from the pipe with the speed this. Okay, this is 20 meter per second. Okay, what is the maximum force required for the from the person holding the hose pipe to prevent it moving backward? Okay, uh, so I'll go to choice. So question number for seven. Okay, rate is force is equal to always ma. Okay, uh, kilogram meter second square. Okay. Okay, so the given data is, or you may say that the mass multiplied by time divided by time. So what is given? The given data is 90 kilometer, a kilogram per minute. Okay, 90 kilogram 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 per minute. When we convert it into the time, that is 60 multiply by velocity. Velocity is 20 meter per second. Okay, this is also a second. So 90 multiply by, so 90 multiply by 20 divided by 60 kilogram meter second square, because the unit are the same. So this is actually the force. Okay. Okay, so that will be a not zero. Zero will be not cancelled. So that will be a 30 Newton. Okay. So this will be a 30 Newton. So that will be the answer. And that will be the force of water. Okay. Force required. Okay. So the answer will be A. The question number 8. Okay. A ball of mass m uh, thrown vertically into the air. Okay, ball of mass m into the air. When ball has speed v, the air resistance acting on the ball. Achha, okay, the air resistance is acting upon the ball. What is the magnitude and acceleration of ball when its speed is v at it rises and fall? Okay, okay. When uh, there are two, the ball is velocity is when ball velocity is upward, when it is raising. Okay, when it is moving toward moving upward. Okay, so this is v. Then g will be a downward, that is a constant. As will be a downward. Both have a same direction. Okay, so so g will be so when that is moving upward, that will be so g so acceleration will be a g plus as. Acha, okay, as is the acceleration due to the resistance, so that will be g fs is given as f. Okay, so this implies that as is equal to F over M. Okay, so G plus F over M. That will be answer. And so on there are two possibility. Now, if if moving downward, okay, if when it moving downward, this implies that G will be a downward, but AS will be upward. So acceleration and the resultant acceleration will be G will be downward and acceleration will be upward. Okay. So sorry, acceleration due to friction will be upward. So that mean G minus F over M. So uh, uh, so this will be answer C. Okay. Question number 9. No, we move toward the question number 9. Okay. What is the question number 9? What is the statement of principle of conservation of the momentum? Okay. The force is equal to the rate of the force is equal to the rate of the change of momentum of the body upon which act. Okay, this is true, but it is representing the Newton's second law. This is related to Newton. Okay, Newton second law of motion. Okay, so this will be not definition of conservation of momentum. The other B part is in elastic collision. This is related, and the relative momentum of body in fact is, but this is equal to their relative momentum, their impact. But it is also for inelastic collision. The conservation of momentum is true for elastic and inelastic collision both. Okay, B choices will be also wrong. The C choices, the momentum of body is the product of this is definition of momentum, not definition of momentum. Not this is not the law of conservation. The total the total momentum system of the interacting bodies remain constant provided no resultant external force act on the system. So D will be the choice. Okay, that will be the true. Okay, so now move toward the question number 10. The question number 10 is the charged particle is placed in the uniform electric field. Okay, the direction of force on the particle is opposite to the direction of the field. The direction of the force on the particle is opposite to the direction of the field. What is the field and what is the charge on the particle? This is uh, placed in uniform field of the force. Okay, if there is a uniform field of force, okay, this is the and okay, this is the uniform charge of the okay, this is uniform charge particle charge electrical charge particle mean electric charge particle according to syllabus of A and AS level exam. The direction of the force on the particle is opposite field opposite to the direction of the field. For example, if the direction of the field is upward, if this is the direction of the field, then the direction of force is the direction of force on the particle, that is charge particle, electrical charge particle. So force is opposite. So okay, it means the force is opposite, but field is so because it is electric charge particle, so the field will be a electric field. Okay, that means this will be a electric. Okay, if this is an electric field, the electric field will be always from negative to positive. Okay, lower potential to higher potential. Electric field always comes from move from negative to, but force is charge is moving. So if this force is the force of the charge in is different. Okay. Oh, sorry, I am saying wrong. Uh, the force electric field is always from positive to negative. So force is so this charge is experiencing force toward the positive direction. Okay, toward the positive. Okay, so it's mean the charge because this is moving toward the positive, mean it not moving. It is experience of force toward the positive field, because electric field direction will be always from positive to negative and force is negative. So this since this experiencing force toward the positive, so charge will be on negative, and electric field and field will be only the electric field is interact with the electric charge particle or charge particles. So, okay, electric field will be electric field. So your answer is A. Okay. So let's now move toward the next question. Uniform rod of the length is 20 centimeter is freely pivot at the point P. Pivot at the point P. And the rod is held horizontally in the equilibrium by 60 Newton on weight. Okay, attached to the rod by a string passing over the frictionless pulley. Pulley is frictionless. Okay, so okay, what is the weight of the rod? Okay, okay, weight as the rod is since rod uniform rod of the length 200 centimeter is freely pivot at the point P. Rod is held horizontally equilibrium by 60 Newton weight that is attached. Acha, okay. The most important thing is the uniform rod. So mass will be so weight since rod is uniform in length, therefore weight will be center. So center mass will be at the center. Okay, this will be weight will be at center. Okay, so if the total length is 200, so the length will be between this and this, that will be 100 meter. Okay, 100 centimeter. Since this is 100 meter, the distance, so the rod is at the center, so that will be equal to 100. Okay, the distance between the pivot and the weight will be which will produce a couple, that will be a 60 centimeter. Why? Uh, so so distance between between P and weight will be 100 minus 40, that will be a 60 centimeter. Okay. So the torque will be, so because this is at equilibrium. So as we know that if we consider the front, yeah, the length in the component along the uh, in the front of the angle, that will be a sine theta. So that will be a 60 sine 30. Okay. So always remember that is 60 centimeter. Okay. So W, we have to calculate the weight of what is the weight of the rod. We have to calculate the weight of the rod is passing through the center of the rod. So that will be the W, the couple will be produced W multiplied by 60 centimeter. And that will be equal to uh, 60, that will be a 60 Newton force sine 30. As so this will be the perpendicular component of this weight. Okay, so this will be the and this force, this will be torque at upward. This will be a clockwise, and this will be a anti-clockwise torque. Okay, or movement. Okay. So what will be the distance between, okay, and this will be the distance that will be a 160 for this from pivot. Okay, why so 200 minus from pivot, that will be the 40 centimeter. Okay, 40 centimeter. Okay, so that will be a W, 60 centimeter is 10 minus 2 meter, and 60 sine 30, and 160 10 raised to power minus 2 due to centimeter. Okay, so that will become minus 2 will be cancelled out, and so W will be equal to 60 sine 30 multiply by 160 divided by 60. This then one, this will be cancelled with this, and this 60 will be cancelled with this, and we know that sine 30 is 0.5 or 1 by 2, and multiply by 160, that will be the W will become 160 divided by 2, that will be 18 Newton. Okay, so uh, answer will be a C, that is 18 Newton. Okay. Okay, so this will be the result. So now move toward the next question, that is okay, the ladder rests in equilibrium on the rough. That is equilibrium. Firstly, it's important to note that is at equilibrium at the rough ground against the earth. Okay, the weight W of the ladder act on the center of gravity. That is W is acting on this. The weight W is ladder act through the center of gravity. Force also act on the ladder at the point P and Q. These forces PQ are respectively. Which vector triangle represent the force on the ladder? Okay. Okay. the velocity will be a downward, okay, because due to weight it will try to move downward, but at the reaction there will be a two forces, okay, one will be upward, okay, and one will be the this direction, okay, the resistance of. So at point P there will be a two forces, horizontal and vertical. The direction will be this, and at Q uh, velocity, due to weight, the velocity will be in this direction, okay, we will be in this direction, and but force will be forces will be the because velocity is the reaction force will be this, and this, okay. So now we try to understand what will be the, so W will be the vertically downward. So okay, so because in D the W is not downward, so that will be a wrong. Okay, now we have choice A, B, so A, B, C. Okay, now let's examine the point force at P. Okay, at force at P we have at P we have this and this. Okay, for resultant we must move toward for resultant we must move toward the, according to head and tail rule, we must the tail of the one vector should be joined with the head of second vector. So for P this will be equivalent, okay, so this will be the resultant of P, okay, this will be the P, okay, resultant P. Okay, now what's about at Q? For Q, the force are uh, for Q, you have this component and this component. When we move toward move it for head and tail rule for addition, this will be this. So this will be a Q. Okay. So this will be a P. This will be a P, and this will be a Q. Okay. This will be a Q. Okay. From this is a P, and the resultant of Q. So from here, the result will be, so the answer will be straightforward, that is A. Okay. Next question is a vertical tube closed at one end is immersed in water. Okay, the column of air is trapped inside the tube. Okay, the density of water is density of water density of water rho is given 100,000 kilogram kilogram in per meter cube. What is difference between the air pressure and atmospheric pressure? Okay, As we know that the pressure on the liquid inside the tube will be equal to pressure of air. Okay, pressure on the water in tube will be equal to pressure of air in vertical tube. Okay, okay. So pressure of air in tube. Now we have to calculate the pressure in air. So, but pressure pressure in at air in tube is actually the pressure due to water around this tube due to water around this plus atmospheric atmos pressure. Okay, the or this is equal to pressure at air in tube minus atmospheric pressure is equal to pressure due to is equal to pressure due to what is the this is the length of water, this is water. Okay, pressure due to 20 plus 30 that is centimeter. Okay, 30 that is equal to 50 centimeter uh, centimeter uh, water around this air enclosed. Okay, this will be equal to this. So that will be equal to, yes, this will be equal to rho is water rho, intensity of rho, g acceleration, gravitational acceleration, and depth, d depth. Okay, so rho is given 100 kilogram, 1000. Okay, 1000 kilogram, and G is 9.8. 50 centimeter mean 10 raised to power in meter if we convert into the meter. So the result will be, now the result will be, if we multiply these, this will be a 4910 EA. So that is that means the answer will be a C. Okay. Okay. So next is rocket 14. Okay. Rocket is fired upward As it accelerated upward after leaving the launching pad, which form of the energy is changing? Okay. Uh, a rocket is fired upward. As it accelerated upward after leaving the launch pad, which form of the energy is changing? The fuel is using, so there will be a chemical energy, potential energy due to gravitational force, and there will be a kinetic energy. I think H answer will be correct. Let's check the other. In B, the kinetic energy and gravitational. So in B, kinetic energy is missing. Okay, that's why this is wrong. The chemical energy and kinetic energy. Here, gravitational energy is missing. Okay, gravitational potential and because the rocket is using fuel, so uh, there must be a chemical energy. So chemical fuel or chemical energy is missing. Okay, so correct answer is only that is A. Let's move toward the next question, 15 question. Okay. Question. Mass M is top of the platform that is posed by the that is supported by gas in cylinder of the cross section area A as shown in figure. Okay, the platform has negligible mass. Number one, the mass is negligible and can move freely up and down. Gas is heated and expand so that the mass is raised through the height h. Okay, the atmospheric pressure is P. Okay, pressure is P. What is the ratio of the gravitational potential energy of the mass? Because it moving, so potential energy as this question is 15. So I must write this is 15. Okay. Uh, 15. Okay. Mhm. Okay. Gain, gain in gravitational potential energy. Gain in gravitational potential energy. As we know that gravitational potential energy is mg, the height is delta h. Okay, this is gain in potential energy. Acha, work done by the other part is work done by the gas. Okay, uh, that will be because the gas is expanding and there will be a gain in potential energy. Okay, the gain in potential energy plus force work. What is the force multiplied with displacement? That is work. Okay, so gain in potential energy plus force pressure per unit. Sorry, so this will be a for because as we know that pressure is force per unit area. So this implies that force is pressure multiplied by A. Okay. So we will get this force is P uh, A multiplied by delta H, the height displacement. Okay. So result will be mg delta H plus PA or delta H. So what will be the ratio? Ratio will be if this is if I say this is a 1 and this is a 2. So ratio from 1 and 2, 1 from 1 and 2 mg delta h divided by mg plus pa delta h. Delta h will be cancelled with this, so that will be mg plus p. That will be and that will be a b. Okay. So let's move toward the next question, and that will be okay. This is okay. Now move toward the next question. Okay, question number 16. The question number 16 is an 18 Newton, 8 Newton. Okay, 8 Newton weight is attached with the lower end of the spring, which is fixed at the upper end. Okay, this is 8 Newton. Okay. Uh, Held at rest, that is important point, at rest at position x, and spring is unstretched. Okay, at this point x it is unstretched. The weight is then released and fall to position y, which is 4 centimeter below x. The weight oscillate and oscillates, okay, and then actually come to the rest at o, which is 2 centimeter. Okay, this is 2 centimeter. Okay, below x. We have to find how much energy lost from the system. Okay, actually, uh, this question is related to the enharmonic oscillation, mean on which the oscillation start like this and then move to this, and due to force the energy will be lost. Okay, so we have to calculate, what is the energy difference at these 2 points. Okay, these are the o point when oscillation stop, and this is the initial point when oscillation is started. X is the point when the oscillation is started, and o is the point where oscillation is completed. Okay, so we have to find the difference of the potential energy loss. Okay, difference in the energy, or we may say that the energy. Okay, y is actually the reference point. We may say that this is the point where the uh, potential energy become a zero. Okay, so gravitational this is not zero, but we take a y if we take y as a reference point y take as a reference point where from where from where we will calculate uh, the displacement. Okay, that will be maximum amplitude. The four, because y will be maximum amplitude. Okay, so from this, so if y is a reference point, uh, total energy, so total energy at x, ex will be, as we know, that will be gravitational potential energy and plus elastic potential energy. Okay, and both at x. Okay, and gravitational potential energy will be mg delta h, because we are considering and and the plus kinetic energy, sorry, and f displacement, delta x. Okay, okay, the maximum delta x will be equal to 4 centimeter. Okay, so as the weight is, this is of equal to weight, that is equal to 8 Newton. Okay, so you have 8 Newton force, that is the weight, and delta x is as is 4 centimeter, mean 4 centimeter mean 10 raised to power minus 2, plus force is also 8, but delta x, because it is starting point, that will be a 0. So spring is unstretched, that's why that will be equal to this. So the result will be equal to 8, sorry. Okay, so that will be a 8 multiplied by so 4, that will be a 32. So that will be a 32 10 raised to power minus 2. Or you may say that 0.32. Okay, joule. Now the what about the delta at sorry, energy at point O, total total energy at TO, that will be EY, that will be equal to, yes, that will be equal to again mg delta hy plus f delta y. Sorry, half k, sorry, one half. Yes, there must be a one half. Okay, mg is again 8. H is 2 10 raised to power minus 2, plus force is one half. Okay, sorry, one half 8, and y is because that is 2 centimeter, so that will be displacement from the position, y is 2 centimeter, and h is also, and delta h is also 2 centimeter. So this is y, and this will be h, that will be a 2 centimeter. Here delta h will be 4 centimeter, and delta x will be a 0. Okay, so delta y will be equal to 2 centimeter to 10 raised to power minus 2. So that will become a 4, that will be a become a 0.24 joule. Okay, so ex is this, ey is this. Okay, so delta e will be ex minus ey. Delta x is 0.32 from here, 0.32 minus 0.24 joule. So result will be 0.08 joule and 0.08 joule, 0.08 joule. Yes, this is the answer B. That is B. So this will be answer B. Okay, because difference is 0.08 joule. So that will be the loss in the kinetic energy. Okay, next question is number 17. That is the uh, according to question number 17, uh, that is the force resisting the motion of the car is proportional to the square of the car speed. The magnitude of the force at speed 20 meter per motion resisting force is the square of the car speed. Mean frictional force is or resisting force is directly proportional to v square. Okay, we may say that that is negative because it will be always in opposite direction. Okay, force acha, the magnitude of force at speed 20 meter per second is 18 newton. So Fr will be, which is equal to, that will be equal to any constant because that is directly proportional according to proportional constant. You may say that that is k minus v square. Okay, okay, and that is equal to uh, the velocity is given that 2 meter per second, mean minus k uh, 2 10 raised to 2 meter. Okay, meter per second. Velocity is 2 meter per second. And and the force is equal to friction because frictional force is given uh, 800 newton and v is given 2 meter per second. Okay, so uh, so this 2 square that will be equal to that friction force is 800 newton. Okay, from this we may find the value of k, that is equal to minus k is equal to 800 divided by 4. That will be a the value of constant will be a of sorry 220 meter. Okay, 20 square of the 20 is 400. Okay, that will become 4 1 and 2. That will be constant will be equal to 2. Okay, so this will be a constant of proportionality k minus k equal to 2. Okay, what is the useful for power is required to the car engine to maintain this speed that is required for v equal to 14 meter per second. We have to find what is the force resistance force. We have to find this. K is given with k is minus k is minus k is equal to 2. So frictional forces will be equal to, yes, that will be equal to 2 uh, 40 square 400 800 newton. Okay, no, sorry, uh, 40 16 32 3200 Newton. Okay, so what will be the power is we have to require the output power is always equal to Fr multiplied by velocity. Okay, so Fr is 3200 multiply by velocity is 40. Velocity is 40, so that will be equal to 1 to 128,000. uh, okay, or in the form, the answer is 1 kilowatt. Okay, this will be in the form of watt. Power always measured in watt, but when we represent 128 in the form of kilowatt, so P will be equal to this 128. So this will be the answer. C will be answer. Okay, 120. C is the best answer. Is only answer. If now move toward the uh, question number. Now we move toward the question number 18. Question number 18 is uh, two wire X and Y are made of the same material. Okay. Since question number 18, two wires X and Y made of the same material. Okay, same material. Y has the diameter twice. Y has a diameter twice diameter and experience the twice. Okay, and experience the twice the twice the tension of X. Mean force is double. The wire obey Hooke's law and have the same original length are the same, both have the same. Okay, so from for question number 18, okay, we have uh, they they have the same extension. Oh, no, so extension is we have to find the extension is different. Okay, as the we know from the definition expression of the Young modulus Y, which is Young modulus Young, that is Young modulus, as we know that has that is actually the ratio between force per unit area and the ratio of extension. Okay, change in length and per unit length. That is the formula of the Young modulus. Okay, because both are made from the same material, so Young modulus will be the same. Okay, so let's calculate first Young modulus for X. Young modulus for X. Okay, let's firstly calculate the Young modulus uh, for X. For X, it will be equal to force per unit area. Area is pi over, you may write as F A. Area is diameter pi d by 2 square. Okay. So in this way, that will be a d over 2 square divided by the extension is delta x, because we are considering the x with delta x over over the length is the same that is given. Okay, so you may write it in this way, f l delta x, okay, pi t by scale. Okay, now by what will be about the young modulus of about y, that will be also force as fy, that will be fy divided by ay, okay, delta y over length is same, so that's why. But force, as it is given that y has a double force, has twice, sorry, twice the tension. Okay, so fy f since fy is equal to 2fx, or you may say that 2f. Okay, so the force is double 2f. Okay, area ay is pi double diameter, pi d by 2 will be cancelled with this, so that will be ay will be equal to a pi d square. Okay, so area will be a divided by pi d square, and extension we have to find, that is different. Okay, length is the same. Since both wire wires are made of same material, therefore yx will be equal to, sorry, y, okay, both will be the same material, so that's will, since both are the same material, so Young modulus will be same, so result will be f l will be that will be a delta x uh, d square. 4 will be moved upward. Okay, 4, and this will be fy will be equal to 1 minute, 2 f l pi, here was a pi, pi, okay, pi d square delta y. Okay, d square pi d square will be cancelled with the pi d square, fl will be cancelled with the fl, so this implies that delta y will be equal to, delta y will move toward here, and delta x move toward here, that will be a 2 delta x divided by 4, and 2 divided, so that will be a delta x over 2. Delta x is equal to e, so e by 2. Delta x is given e by 2. Okay, that way the answer will be e by 2. B. Answer will be a B. Okay. So move toward the next question. What is the representing of the gradient of the graph of force vertical axis against the extension horizontal axis? Question number 19. Okay. Okay. What is the representing of the gradient of the graph of the forces along the vertical axis, forces along the vertical axis, and against the extension जो f extension है that is delta x that is along the horizontal axis. Obey the Hooke's law. Okay. And okay. Okay, what is the represent of the gradient? Gradient, we have to find the gradient. Gradient mean uh, this, that is theta. So tan theta will be f over delta x. Okay, and that is the as we know that that will be a k, that is the spring constant. Okay, spring constant. So this is spring constant force uh, divided by extension ratio. Okay, so that will be so spring constant. So there is a B. Okay, so next question is question number 20. Okay, uh, force are applied to the end of the rod so that the length increase. Okay, the variation of the load L is represent the force. Okay, the extension of the rod is shown. Okay, this is actually the force. Okay, load is a force. Acha. Okay, the point P is elastic. P point in elastic limit. Okay, that is elastic limit. So which area should represent the work done during the plastic deformation of the rod? Okay. As we know that work is all which area represent the work done during the elastic deformation. That will be a force multiplied by extension. Work will be force multiplied by extension. Okay. So force must be so actually force must be along the y-axis. Force must be along vertical axis, and extension must be along horizontal axis. Okay, so if we consider the orientation for so this will be A will be a wrong. Okay, so we must say that uh, according to above the orientation will be like this. The L will be along this and E must be along this. Okay, uh, this will be a B. Okay, part the question B will be replaced with the this. Okay, so L along this and E extension will be along this. Okay, so So if this like this, then and but this will be actually the total work and the applied and then the evaluation of the extension rod, the work done, total work, okay, due to load, okay. So that will be like this. So we have, so this is so this will be A will be a wrong, okay, because the L we have not considered the area. We have to consider the shaded area along. So uh, we have to consider have to consider shaded area along extension. So that's why A is wrong and D is also wrong. So, but B is also wrong because it is representing the total work done by raw by load. Okay, but the question is the plastic deformation of the rod, deformation. If we consider this area is if we consider this is work done during elastic deformation, during elastic deformation, while so this is actually the uh, plastic work done during plastic deformation. Okay, deformation. So correct answer will be a C. Okay. So our correct answer is C. Now move toward the next question. Uh, the graph shown in the variation of the quantity P with Q. Q for the sound wave traveling in the air. Okay. So which could P and Q be? Okay. We have shown the variation of the P with the Q for the sound wave traveling in the air. Okay, as we know that uh, uh, so as we know that uh, when for sound wave traveling in air, we have of we have velocity is actually equal to frequency over wavelength. Okay, multiplication of force and velocity, and this implies that force is inversely proportional to wavelength. Okay, so here P and Q are directly proportional, so that's why that is stationary wave. Acha, okay. A is amplitude. Amplitude, I mean amplitude. If we consider this amplitude, amplitude and intensity, but intensity is actually directly proportional to A square. Not I is directly proportional to A. So this will be so this is, but this graph is directly proportional. But from graph, P is directly proportional to Q. So this relation is, so A is, so from this, uh, graph is for directly proportional. P must be directly proportional to Q. So this is a wrong. This is a wrong. Other is, frequency is wavelength. Okay, but frequency is inversely proportional to wavelength. Not frequency is directly proportional to lambda. So B choice is also a wrong. Okay. C is speed. Speed is constant. Speed is constant or proportional. So that is constant. So this will be also wavelength. This will be a correct, uh, because frequency is directly proportional to wavelength, or you may say that wavelength is inversely proportional to frequency, but that is directly proportional to time. So that's mean lambda is directly proportional to time. So the choice D is the correct. Okay. The question number 22. Now the question number is 22. The vibration generator produce a, progressive wave on the rope. The diagram shown in the rope at one instant, the wave travel at the speed 4 meter per second. Okay. So what we have to calculate, what are the wavelength of the frequency, wavelength, and we have to find the wavelength and frequency of the wave. Okay. Say, approximately this is 0.1. This will be, sorry, this will be at center. This will be a 0.3, and this will be a 0.5. Okay. So if we consider this is a wavelength. Okay, this. Uh, so this will be the wavelength. Okay. And what will be the wavelength? Wavelength will be uh, less than 0.322 and greater than 0.2. Okay. So greater than 2 and less than, so these only possible. A and B is not possible. So the choice is given this. So that's mean this implies that, because this, so that implies that lambda will be less than, so that will be a 0.27. Okay. What is the frequency formula? Frequency is actually the V over lambda. So V is given, V is 4 meter per second, and lambda is 0.27. So that after calculating, this will be a 14.82, near to 15. Okay. So this will be a 15. So the best answer is C. Okay. So C will be asked. Now we move toward the next diagram. Okay. Question number 23 is the diagram shown in the waveform of the signal displays on the cathode ray oscilloscope. Time is along this axis. Okay. 5 meter per second per division, okay, along the x-axis. And y is 5 y is 5 meter volt per division, okay. So we have to find the amplitude, okay. Your line, and this okay, amplitude ampli amplitude will be 1 and 2, so amplitude will be 2 multiplied by amplitude is 5 meter per is along the y 5, so that will be equal to 10 volt meter, okay. Amplitude will be a 10 volt meter, so A and B will be possible, so this will be around. Now about the frequency, as we now taught now, the frequency is not given, but frequency is equal to 1 over time period. Okay, we have to time. Yeah, time is okay, this is time. This is time period. Okay, so, this will be a time period. Because it is starting from 0 to no, sorry, wrong. I'm wrong. Time period, you may take the time period time period, you may calculate from this to this, okay. That is 1 2 3 4, okay. uh, 1 2 1 2 3 4. So time period will be a 4 division per division is 5 multiplied by 4, okay. So that will be equal to time by so millisecond, okay. Milli mean 10 raised to power minus 3, because that is millivolt. Frequency must be a millisecond because it must be measured in 5 milli mean 10 raised to power minus 3 per second per division, okay. So that's why this will be equal to this. So this become 10 raised to power minus 10 raised to power 3 uh, 20, or you may say that 10 raised to power 2 10 raised to power minus 1, or 0.5 10 power 2, or you may say that 50, okay, 50. So this will be the answer. So A will be your answer. What? Okay, the answer of this question is A. Now we move toward the question number 24. The question number 24 is about the jet aircraft jet aircraft travel with the speed 0.8, where v is the speed of sound. Aircraft approach a stationary observer approaching to approach. The frequency of the sound emitted by the aircraft is 100 hertz. Okay. 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 So as we know that if the source is approaching to observer, then the expression is frequency observed by the wave will be equal to frequency uh, emitting from the source and velocity of the wave divided by velocity of wave minus velocity of the wave velocity of the source, where Vs is the velocity of source. Okay, so this is the expression. Okay, as the frequency frequency of source is given, that is 100 hertz. Velocity is v, the and the velocity of sound wave is v, and the velocity and velocity of the speed of aircraft, as it is mentioned that speed of aircraft is zero point 0.8. So that will be a zero point 0.8 v. So the result, so that will be equal to, okay, so that will be 100 minus 100 volt minus 1 minus 0 0.8 uh, volt will be cancelled with this. So 100 divided by 0 0.2. You may write 10 power 2. Okay. To 10 raised to power minus 1. Okay, so this will become 1 over 2, 10 raised to power 3. 1 over 2 is equal to 0 0.5, 10 raised to power 3. So that will be equal to 500 hertz frequency of observer. And so this is D is answer. D. Okay, the next question. This was 24. Okay. The next question is 25. So 25. Okay. A telescope detect and analyze some electromagnetic radiation of the wavelength is 2 centimeter. 2 wavelength is 2 multiplied by 10 raised to power minus 2 meter. Okay. So so which type of telescope is microwave television telescope, optical telescope, radio telescope, or X-ray telescope? As we know that uh, we may observe it from the with the help of graph. Okay, 10 raised to power 3, then that will be represent the radio. Okay, if 10 raised to power minus 2, then that will be representing by the microwave. If the wavelength is 10 raised to power minus 5, that will be represent infrared, and so on. So it if the wavelength is if the wavelength is the largest wavelength is 10 raised to power 3, that is radio wave. And then so if we increase the frequency, the maximum frequency is about the is related to the gamma wave. So as the question is about 10 raised to power minus 2, so that will be the answer will be a microwave. Okay, so answer of 25 will be A. Okay, because that is representing the this wavelength is smaller than the radio wave, but this will become in the microwave. Okay, the next question is 26 question is what may be used to produce stationary wave? Blowing air over the top of empty bottle. A. Okay, yes, we have seen that if the bottle is closed, and then it will produce the wave like a stationary wave. It will produce a stationary wave like it may be a maybe like this, or this may be like this, or this is fundamental, this is first, and this is second, and so there are one loop there. Here will be a two loop, and this will be a two loop. This is one loop, okay, and this will be a zero loop, okay, zero loop, and this will be lambda by 4, okay. So the A is true, making loud near to the making loud sound near to, this is related to diffraction. Diffraction. And passing mono C is so that will be not passing monochromatic light through that will be related to interference, as we know that it will be interference. And the passing water wave through the this is also related to diffraction. Diffraction, okay. So A is only the produce the stationary wave. B is making sound, making a loud sound near mountain will be also will be related to diffraction. Passing monochromatic light through double slit, as we know that double slit experiment is related to interference, and phenomena is related to end. So C is also wrong. D is passing water wave through narrow slit. So passing through narrow slit mean there will be a bending, and that will be related to diffraction. Okay, so that will be also wrong. Now we move toward the next question. That is the what is the example of uh, what is the example of diffraction of the wave? Acha, diffraction. Uh, as I have already explained, diffraction mean the bending of light through the narrow edge. So we A is laser. The choice A is laser light traveling along an optical fiber. Laser light traveling along the optical laser light traveling along optical fiber. So that is also that is wrong. Light wave forming image on cinema screen. Light wave forming that optical phenomena. Microwave passing through the edge of the metal. Edge is related to, okay, that will be true. Sound wave uh, reversing as pass through air. That is also a wrong answer. So C will be the answer. Okay. The question number 28, uh, when light from two lamps fall on the screen, no interference pattern can be obtained. Why this is light from two lamp two lamps fall on the screen. The so the lamp are not point source. Source is wrong. The lamp emit light of different amplitude. Wrong. This is no, the light. So that will be not coherent. Light from the lamp is not coherent. The light from the lamp is white. That is wrong. Only the answer is D. Why that is D? Because the that is mentioned that light coming from the two lamps. So s- sources are different. So they will not produce a coherent wave. Okay, so that's why the sorry, I have written the answer D. D is a wrong answer. Uh, Actually, answer is C. I have selected C, but mentioned. So answer is C. Okay, next question is 29 question. 29. 29. Acha, okay. A beam of light consists of two wavelength, that is two wavelength, this and this. Refracting grating, that is given produce a refraction pattern in the which the second order of one of these wavelengths occurs at the same angle theta, and third order of the. Okay, the beam of light consists of two wavelengths. So wavelength are okay. So what we have to find the what is the angle of theta? Okay, actually, uh, there are two wavelength. Lambda one is 436 nanometer, or you may say that 436 10 raised to power minus 9, and the other is lambda 2 is given 654 nanometer. You may say that 654 10 raised to power minus 9. Okay. Okay. Refraction grating, sorry, numbers is given, and one is number is n is given 2, and one is given 3. So as we know, both are different. Okay. So to differentiate, one wave is related to number 2, because at the same angle theta, in which the second order of one of these wavelengths occurs. N 2 stand for lambda 1 or lambda 2, and 2 and prime is stand for one of them. Okay. One of number is along with the one wavelength, and other number is related to the other number. But since we know that as lambda will be increased, we know that as lambda will be increased, uh, जैसे when lambda will be increased, numbers of the wavelength, because the screen length is constant. Here the screen length will be remain the constant. So if lambda is increased, the numbers will be decreased. Okay. So or if lambda is decreased, then n will be increased. So from this, since this implies that n equal to 2 is larger lambda, yeah, n is equal to 2 for lambda equal to 6, 5, 4, 10 raised to power minus 9. And this implies that n equal to 3 is for lambda uh, is because because wavelength is decreasing and n is increasing, so n is larger than 2. That's why the wavelength will be smaller. So wavelength is that will be a 4, 3, 6, 10 raised to power minus 9 for this. Okay. So it's mean, but we know that the expression is uh, d sine theta is equal to n lambda, where d, d is number of line is per meter square is 1 over 5 10 raised to power 5. So putting all these value in this, so for n equal to 2, your will answer will be 1 over 5 10 raised to power 5, that will be equal to 2, and for 2 and equal to 2, there will be a 6 5 4 10 raised to power minus 9. Okay, so sine theta, sir, that's it. So theta will be equal to sine inverse of 5 5 10 is to power 5 multiplied by 2 multiplied by 6 5 4 10 is to power minus 9. Okay, uh, so that will be if we consider that, that will be a sine inverse of, that will be 0.654. Okay, that, and that will be a 40.8. So that this will be your answer. So this is answer C. Uh, you may also calculate for you may you may calculate it for n equal to 3 with for n equal to 3, lambda is 4 3 6 10 raised to power minus 9. The result will be same, sine inverse of 5 raised to power 10 5 3 4 3 6 10 raised to power minus 9, and that will be again theta is equal to 40.8. Both answer is the same. Okay, so the answer will be question number 29, answer will be a C. Okay, that okay. Now move toward the question number 30. Question number 30 is about which diagram shows the electric field line surrounding an isolated negative sorry isolated negative point charge. Okay, for so electric field, these two are for the magnetic field, magnetic lines. Okay, magnetic field line around electric charge. So these are wrong for uh, because electric field surrounding the isolated negative point charge. So there is a negative charge, and that is a negative charge. So negative charge. So because it is a negative charge, electric field always from positive direction of the electric field always from positive to negative. So that's mean the B will be a right answer. Okay, so B will be a right answer. Okay, so no move, no move to toward the next question, that is 30 first. Okay, okay, beam of electron is directed into the electric field and is reflected by it. Okay, the diagram 1 represent the electric field in the plane in the electric field in the plane. Okay, plane of paper. Diagram 2 electric field perpendicular to the plane of paper. Okay, The line A, B, C, D represent the possible path of electron beam. All paths are in the plane of the paper. Okay, all paths are in the plane of the paper. That is important point. Which line represent the path of electron inside the field? Okay, because in this uh, here in diagram 2, the electric field is perpendicular, but the path is along the paper. Okay, in the plane of paper, but electric field is perpendicular to the paper. And but so deflection is in diagram 2, the deflection is not along the electric field. So every electron is always deflected due to the electric field. So its reflection must be toward the electric field. So this diagram is totally wrong. So move toward the diagram 1. In diagram 1, electron must move to the positive direction. So B, because um, 31 diagram is totally wrong because the deflection of electron path is not toward toward the direction of electric field. Direction of electric field is perpendicular to page, while uh, deflection of electron on page. So diagram 2 is wrong. What about the diagram 1? Diagram 1. Direction, deflection, charge on electron is negative. So deflection will be toward positive. And electric field lines always from positive to negative. So answer is, so B is answer. So B is true. Okay. The question number 32 is now the question is 32. Question number 32. Okay, sorry. The charge particle of charge Q mass M is initially at rest. Okay, initially at rest, uniform electric field. The field is produced by uh, parallel metal plates separated by distance. D. It is like a capacitor, okay? Having potential difference V between them. What is the expression for the acceleration of the charge on particle? Okay. Okay. 32. Explanation of 32. As we know that the potential phi is always equal to work done per unit charge, and work done will be equal to force multiplied with displacement per unit charge. So that will be equal to this, and uh, from here we may find that F equal to Q phi, okay, Q phi over delta L, okay, but F is equal to ma Q phi over delta L, okay, and A will be equal to Q phi and m delta L. So this will be the expression, okay. So by putting all these value, okay, the Q phi is representing by the, you may say that phi is representing by V in above expression, mass and D. So this is okay. So this will be the answer. Okay. Okay. D, this will be answer. Okay. D, because QVMD. Yes, that is. Okay. Now we move toward the question number 33. Okay. This was about the question number 32. Now we move toward the question number 23. But for to solve the 23, I need a space. So if you have noted all these points, let me erase. Okay, so because I need a space, that's why I have to delete it. All these things. Okay. So now we move toward the question number 23. Okay, for 23, okay, I think I should erase this too. Make a space. Okay. So 23, 33. Okay, for 33, I need a space. That's why I have to erase. Question number 30. When there is a current is 5 ampere in copper wire, the average drift velocity of free electron is given this. Drift velocity is given this. When the average velocity is different copper, now there is wire 2, okay, has twice the diameter. Diameter is twice, wire is copper wire is same, okay, and the current is 10 ampere, okay. So what is the average drift velocity? We have to calculate the average drift velocity. Okay, question is very clear and simple. Actually, the expression for current is, as we know, that N A is represent the area, Q is number of Q is charge, and N is the number density, number of free electron, Vd is the drift velocity. Okay, okay. When current of first is 5 ampere, okay, that and area is given that so area is pi r square 10. When the current is 5 ampere, okay. In the copper wire, the average velocity of free electron current is 5 ampere, and current is 5 ampere, and average drift velocity is given of 8, 10 raised to power minus 4. Okay, when the average current is 5 ampere, and the average drift velocity is 8, 10 raised to power 5 meter per second. Okay, okay. What is the drift velocity? We have to find the Vd, that is the given for this. We have to Vd prime when current I is equal to that is given 10 ampere, that you may say that uh, multiplied by 5 ampere, you may say that that is equal to I. Okay, drift velocity of the wire, the diameter is twice. Acha, okay, and current is also twice because current is 10 ampere, and diameter area and diameter is twice. A dash diameter D is 2. Okay, okay. So these are the all given. The diameter is replaced with this. Okay, so from all these given data, as I dash equal to I dash is equal to 2I. So by putting formula of this, uh, because they both are the made from the same copper wire, so this implies that N dash equal to N, and Q dash will be equal to Q. That is also an important point because both are made of copper, means same material, same material. So that's why they are the same. So by putting the values N dash, A dash, Q dash, VD dash, okay. So by putting the value N dash, uh, D dash, sorry, N dash, A dash, Q dash, VD dash, that will be equal to 2 N A Q V T. Okay, N is equal to N dash is equal to N. A area A is pi r square. Okay, pi r square mean pi dash square. Okay, and Q is same, and VD we have to calculate, that will be a different. Okay, 2 N A Q V T. Okay, so N will be cancelled with this N, pi with, sorry, N pi R square Q V T. Okay, pi will be cancelled with this pi, N will be cancelled with the N, pi will be cancelled with the pi, and Q will be cancelled with the Q. Okay, R mean d dash over 2 square VD dash 2 R square VT. Okay, sorry. Here R is also a T by 2 square VT. Okay, but T, okay, so that will be 2D. Okay, this 2 will may cancel with this 2. Okay, so this will be a 2D square VD dash 2D square VT. Okay, you may say that D square will be, or you may write in 4D square VD dash 2D square VT. Okay, this VD will be, sorry, VT. D square will be cancelled with this 2 is by 2. So VD dash will be equal to VD half. And VD is given 8 10 raised to power 8 10 raised to power minus 4 ms 1 divided by 2. So answer will be a 4 10 raised to power minus 4 meter per second 1. So this will be our answer, and that is A. 34. Okay, what is the equivalent to 1 volt? Volt is work per unit charge, and work is unit of work is joule. Work is energy, and that will be a per coulomb, joule per coulomb. Sorry, per coulomb. Okay, so the answer is B. Why 1 coulomb per second? Uh, Q over time is represent the current, so that's why that is wrong. Okay, this is right. Okay, and that is from here. Okay, 1 joule per second. Uh, this is power, energy per unit time. Okay, yep, work per unit time. This is power. Okay, power. So that's why this is also wrong. 1 joule per second. 1 joule work, and this is work per charge per time. So this is also wrong. So only the answer is D. Okay, that's why. Okay, next question is about the diagrams. Shows are the next question is 35. Okay, the diagram shows a rectangular block with diagram x to x and okay, x x 2x and 3x. Okay, this is diagram. Okay, the electric contact can be made to the block between opposite pair of the faces. For example, between the faces labeled R. Okay, which statement describes the electric resistance of block? Which statement describe the electric resistance of block is correct? Number one, it is maximum between the faces labeled P is maximum between Q. Okay, the length between R and R. Firstly, we have to see the first is A is about the face PP. So P and P between distance between distance between P and P is P is X. Distance between Q and Q is 3x according to figure, and distance between R and R is 2x. Okay, and as resistance is directly proportional to length, so maximum resistance so maximum resistance will between Q to Q. ठीक है, okay. uh, length is equal to 3x, so Q between Q. Okay, so that is Q between Q. Okay, so B will be correct answer. B will be correct answer, remaining all. And D is the same because length are different, so that is it is same with whichever the pair of the faces use. That is absolutely wrong because length are different, so the resistance will be different. So now we move toward the next question. 36. Okay, a battery which have internal resistance. Okay, this has internal resistance is connected. One is it has an internal resistance is connected parallel arrangement of two resistors. So as shown. Okay. Uh, okay. Initially, S is a switch is open. Okay. And what happened to voltmeter and meter amplitude when switch S is closed? Okay. So it is between relation. We have to find the meter reading. What will be effect on meter reading and ampere meter current? Ampere meter reading mean current. What will be the differences? Okay. So 36. Okay. As when S is switch is open. If I say this is RA and this is RB, okay, current will sorry okay actually this point for voltmeter, this is same as if it is connected with the these point. Okay, voltage will be same for voltage drop will be same for battery terminal or at point A and B across resistance. So if I would connect it here or connect the if I replace this voltmeter, if I connect the result will be same. Okay, so if S is open, when S so this is not true, only true for when so when S will be open. Okay, when switch is open uh, when this is open, voltage will drop only across RA. But when when S will be closed, we will drop across or A as well as or B parallel to each other. As our resultant resistance will be 1 over R A plus 1 over R B minus 1, because both RA and B uh, are parallel to each other, so that will be, so it will less than R A. So because resistance is, so R is decreasing. As R is decreasing, this implies that V will also decrease, because when resistance is decreased, then resist So that will be decrease. So it's mean because voltmeter, so C and D will be wrong. Now the A decrease and decrease. Okay, but V is equal to I R. Okay. Okay, and when current is decreasing, sorry, when current is increasing, so when resistance is decreasing, resistance is decreasing, I will be increased. I will be increased. So the answer will be this, and this will be wrong, and the answer will be I. Next question is 37. Okay, battery is connected to network of the six resistance uh, as shown in figure. Okay. The potential difference across the five of the resistance are labeled on the diagram. Okay, what is the potential resistance, potential difference across the resistors or resistor R? Okay, as we know that the voltage will be the same for this and this terminal. Okay. Oh no, sorry, not this terminal. The voltage will be same as for other. So, or for this and voltage drop across this will be the same. Okay, so then we don't need about we don't need to be care about one by so we don't need to this. Okay, so we may solve it directly. Okay, okay, uh, 4.1 V 4.1 plus 3.7 must be equal because all the uh, these are in series. Okay, so that will be a 2.2 plus 1.2 plus R. From here R may be calculated, that is 4.1 plus 3.7 minus 2.2 minus 1.2. That will become 7.8 minus 3.4, and that is equal to 4.4. So that will be our answer 4.4. So the answer will be A. Okay, uh, that is true. Next question is 38. Okay, diagram 38. Diagram shows a battery. The battery EMF is 6 volt connect in the series. Acha, okay, connected in series with the resistor of uniform resistance RQ of length 60 centimeter. The resistance of RQ is equal to resistance of resistor. That is very important point. They are equal. Okay. RQ mean RQ mean uh, from this point to this point. That is RQ. And this R given is that R resistance resistance of RQ. Okay. So resistance of RQ is equal to, if I say that this is X, is will be equal to Rx. Okay. So when this length is equal to maximum length RQ, that will be equal to the resistance X. Okay. So resistance will be equal. Okay. So VRQ, what will be the VRQ? Because these are all in the series. Okay, that will be resistance of R Q divided by RQ plus that plus X, okay, and multiply by EMF, that is volt, okay. And since these are the equal, so Rx, because RQ is maximum resistance, that is equal to X, or sorry, yeah, this is Rx, okay. So this is because R is also multiplying. I should write that is 6 volt. Okay. That is Rx divided by 2 Rx multiplied by 6 volt. Rx will be cancelled with the 6, 2 will be cancelled with the 3. So VRQ, which is maximum, okay, RQ, that will be a 3 volt, okay. So since VRQ, since RQ is L maximum, this is maximum length, so this is maximum resistance of L, okay. So when L maximum or or is also maximum, this implies that VRQ will be V maximum. That means that will be a maximum. Okay. So which graph shows the variation of the length as and so we have 2 point. One is this is maximum, and that is equal to maximum value is and this is V maximum. Okay. And this is a V max. Okay, I must say that uh, VRQ, which is V maximum, and that must be a 3 volt. Maximum voltage value must be this. Okay, this is very important point. This is a 1 and 2, and those, the second is because and second is V is directly proportional to L. Okay, so there will be a this will be a second. So that is there is a 2 point. Okay, one maximum voltage must be a firstly V must be directly proportional to L. So V must be a 0 at 0, and that must goes to directly proportional, that must be increased. So these two are wrong. Maximum from 1, the maximum voltage must be equal to 3. So mean that if we that is 3. So B will be a correct answer. Okay, from 1. It is satisfying both 2, 1 and 2. Okay, from 1 and 2, because V maximum is 3 volts, so that's why this will be good. Now we move toward the next question, question number 39. Okay, 30 according to 39. Okay, a nucleon emit beta minus particle. What is the change to the proton number and to the nucleon number of the nucleus as from the uh, as from let's suppose uh, the initial particle is A, okay, and X and Y, okay, atomic so proton number is X and nucleon number is Y. That will be decaying into a new particle. Let's suppose that is R, and that is decaying the beta particle. Beta minus one has a, a minus one, and that will be proton number is zero plus antineutron. Okay. This will be increased X plus one, but there will be no change in the nucleon number. That will be remain the Y. Okay. So the question is uh, change. We have to not. The question is not about the proton number or nucleon number, but change in proton number. Okay. So in the change. So what will be the change as in a proton number? Proton number change in proton number. Okay. So firstly we have to find the change. Change in proton number that will be equal to x plus 1 minus x, that will be equal to 1, and change change in uh, linear numbers, that will be 1 sorry, that will be x, sorry, that will be equal to y minus y, that will be equal to 0. So 1 and 0. Change in proton number is 1, and change in nuclear number is 0. So D is answer. Okay. So D will be answer. Uh, the question number 40. 40 is how many up quarks and how many up quarks and how many down quarks. And this is the one. Okay. CL 1737. So proton numbers is equal to 17. Okay, and nucleon numbers are number is 37. So so proton number of proton is 17, and number of number proton and neutron will be equal to 37 minus 17 neutrons. Okay, so that is equal to 20. Okay, so we have 17 proton, okay, and 20 neutron. We may say that proton we have a 17, and neutrons which are 20. Okay, but we know that uh, proton are made up from two ups, one down, and but similarly neutrons are made of two one up and two down quarks, and so we may write that there are two ups plus 17 down. From here we have 20 up plus 20 multiplied by 2 down. Okay. So when we combine these two, 17 multiplied by 17, 17 multiplied by 2 is 30, so that's mean 34 up plus 17 down, and here is 20 up plus uh, 40, 40 down. So 34 plus 20 up, 17 plus 40 down. So that will be equal to 54 up and 57 down. 57 down. So 50, this will be the answer. 54 ups and 17 down. So B will be a correct answer. This is end of exam. Thank you very much. I have explained each and every step very clearly. If something may be confusing for you, or if you have some reservation on the any solution you want discussion, please uh, put your feedback on the comment box, or your confusion in a comment box. I will try to answer your questions or queries as soon as possible, inshallah. So and subscribe my channel. Thank you very much. Thank you.